In the previous classes, we discussed about what is the relation between E and V. According to potential gradient, the relation between E and V is E equal to minus del V. Let us consider a numerical problem. The potential for a certain surface is given by V of xyz equal to 300 by x plus sine 0.1 y plus ln xy volts. That is, ln is the logarithm xy, log of xy volts. Find E bar at a point P 1, 0.6, 0 meters, where x and y are in meters. This is the numerical problem. We are using simply E equal to minus del V formula. That is, we already know V is given as 300 by x plus sine 0.1 y plus ln xy. We want to calculate E bar. E bar means electric field intensity. Electric potential is given. Electric field intensity we have to calculate. E equal to minus del V. This is the divergence theorem we are applying to find E bar. First we have to calculate. They given that V of xyz is 300 by x plus sine 0.1 y plus ln xy. They given. E equal to minus del V. First we have to calculate minus del of V. Del of V we have to calculate. That is minus del V equal to, what is the del operator? Del operator is dou by dou x of ax plus dou by dou y of ay, dou by dou x of, or any vector, it is dou v vector, it is v vector dou v by dou x ax plus dou v by dou y ay plus, it is a unit vector, plus dou v by dou z, dou v by dou z az. This formula we are applying. We already know that what is del v or del a. The vector operator del v is, del may be written as dou by dou x plus dou by dou y plus dou y by dou z. Here we are applying v. In place of any vector we can apply the divergence of any vector. Del a we already know. In the previous class we discussed about what is del a, del d. E equal to minus del v we derived previously. Now we are applying dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. Now here it is v, it is the x term, it is the y term, it is the z term. Now we are applying this del operation. First we are calculating dou v by dou x. Dou v by dou x equal to dou v by dou x partial differentiation of v of xyz, that is minus 300 by x square. We can write, what is the 300 by x differentiation is minus 300 by x square plus here sine 0.1 y is there. Here sine 0.1 y, the differentiation of sine 0.1 y with respect to dou y, dou v by dou y, dou v by dou y we are carried out, plus 0 it is, because sine 0.1 y it is the partial differentiation with respect to x, it is 0 plus ln xy, or it is log xy, it is log xy is 1 by xy. 1 by xy we can write 1 by xy into y, 1 by xy into y, that equal to minus 300 by x square plus 1 by x. Here y get cancelled, 1 by x we can write. Now similarly we have to calculate dou v by dou y, dou v by dou y for that equation, potential equation given by 300 by x. 300 by x is here, y term is not there, hence it becomes 0. You can see this 300 by x, here y term is not there, hence it becomes 0. That we are writing here. After that sine 0.1 y 0.1y. Here y term is there. Sign differentiation is cos 0.1 y 0.1 cos 0.1 y plus 1 by xy into x, dou x by dou v by dou y differentiation we are doing. Let us see that. Dou v by dou y becomes 0 plus 0.1 cos sign differentiation is cos, hence cos 0.1 y plus logarithm of xy is 1 by xy into, here y term becomes 1, log differentiation of y is 1, only x will come, x gets cancel, that equal to what we can write, 0.1 cos 0.1 y plus 1 by y, we can write dou v by dou y. Similarly, we have to calculate dou v by dou z. Dou v by dou z for this. Dou v by dou z we are calculating for this. Here this term becomes 0 and this term becomes 0, and here z term is not there. Here also z term not there. Here z term is not there. Hence dou v by dou z equal to 0. Hence dou v by dou z equal to 0 plus 0 plus 0, that equal to 0. Therefore E bar equal to electric field intensity, E bar equal to, we are substituting all this, that is minus of del V. We are substituting all these equations here, this equation and this equation plus 0. After substituting that, you will get what is E bar. E bar, one equation will get. At that, on that equation we have to substitute x, y, z as 1 is x, y is 0.6, z is 0. Okay, let us see that. E bar equal to minus of minus 300 by x square plus 1 by x into ax plus 0.1 cos 0.1 y plus 1 by y. We are substituting that ay it is. Z term is 0 az plus 0 az. We substituted. Simply we are substituted. At this point, at a point P is given as 1 comma x is 1, y equal to 0.6, z is 0. We are substituting all this in this equation. If you substitute all this equation, what we can substitute? In place of x we can substitute 1 square. In place of y we can substitute, it is also 1. Like that, if you substitute E bar, you can get 299 ax minus 1.766 ay volts per meter. This, like that, we can calculate electric field intensity from electric potential by using potential gradient.